Welcome to Chemistry 51. Chapter 1 is on matter and measurements. On this table, we have equalities between English and metric units. And we'll be using these equalities in order to convert from either an English to a metric unit or vice versa. For example, I have 1 inch is equal to 2.54 centimeters, or 1 meter is 39.37 inches. So you will always be given the equalities between an English and a metric unit. This is not something I need you to memorize, but we will be using these to do calculations to convert from one type of unit to another one within the English and the metric units. Here's a conversion between feet to meters. Now, in order to convert between English and metric units, we're going to follow a set of rules. Primarily what we're going to be doing is we're going to be either multiplying or dividing units in order to cancel that units to go from one unit to another. So we have a set of rules for solving our word problems. The first one is going to be writing down your given quantity in its units. So our problem here is how many quarts of Coke are in a 2-liter bottle of Coke. So we're basically going to dissect this word problem, figure out what we're given. We are given 2.0 liters, okay? And then we're going to write down number 2, the quantity you're asked to find. We are looking for quarts of Coke. Now, number 3 is determine the appropriate equality relationship between the given and the find units. Now, you can get this information from the table we previously looked for, or it's going to be written right into the word problem for you. This is nothing, again, you would have to memorize. So in this case, when we look at our table, we have 1 quart is equal to 0.946 liters. So this is the important piece of information because we're going to use that to create what we call a conversion factor. Conversion factor is the equality that relates the units we're looking for and what we're trying to find. And we take that equality and we write it in a fraction format. So we could write this equality in a format of saying 1 quart divided by 0.946 liters, or 0.946 liters over 1 quart. The quart and the 0.946 liters are equal to each other. That's why we can write it in this kind of fraction format. That's what we call our conversion factor. So it's important to know how to create a conversion factor. Okay, step number 5 is setting up a solution map. Now this is sometimes known as a road map. So you can think about if you are going from point A to point B, you need to follow your map of how you're going to get there. So this is sort of key to setting it up. So you're going to write down your given quantity. So in this case, our given quantity was 2.0 liters. And now we're going to multiply it by our conversion factor. And we had 2 to choose from on the previous page. We are going to pick the one where our units will cancel. So we have liters here. We're multiplying it by a fraction, so our fraction must have the liters on the bottom. So the one we want to pick is the one with the liters at the bottom, which was 0.946 liters, is equivalent to 1 quart at the top. And that's going to give me my answer in quarts because my liters will end up canceling each other. And that's what I want to find out. So this part is sort of key, knowing how to set up a conversion factor so your units will cancel. This will always get you to the right answer, that you don't have a question, do I multiply or divide this number? If your units are set up appropriately, so always write those units down, you should be able to attain the right answer. So the next step is just solving the problem, is doing the math. So again, you cancel those units to get the information you're trying to find. So 2 liters times 1 quart divided by 0.946 liters gives me 2.114164 quarts. And again, you can write down however many decimals are on your calculator. If you don't have that many set to it, it's okay. Because your final step here is determine the correct number of sig figs. Conversion factors are not used for determining sig figs. Those are going to be what are called exact numbers. You're going to use the number given to you in the problem. So 2.0, we had 2 sig figs. Our final answer must have 2 sig figs. So that will be 2.1 quarts. And again, include the units. Another thing to think about when you get to your final answer is do what I call is a reality check. Does your answer make sense? So if we think about here, we said that a quart is a little bit bigger than a liter. So our final answer, we have 2.1 quarts is equivalent to 2 liters. That one is a little bit bigger. So yes, our final answer does make sense. So you can kind of check yourself at the end just to make sure that you are approximately what you think you should be. Okay, let's do our next example. The distance from Pierce College to Santa Monica is 48 kilometers. How many miles is this? So we're going to follow the same steps we learned previously, is always write down what you're given. So in this case, we're given 48.0 kilometers. Now, what are we trying to find? Here is miles. And now we need a conversion factor. So again, you can go look this up on a table somewhere. And we'll want to know the relationship between miles and kilometer. So 1 mile is equal to 1.609 kilometers. Now we need to set up our solution map or a road map so we know where we're starting and where we're going to. So we start with what we're given, which is 48.0 kilometers. We're going to multiply it by the conversion factor. So again, we have the equality. The equality becomes the conversion factor. We want the kilometers at the bottom so they'll cancel. So we have 1.609 kilometers is equivalent to 1 mile. And then to solve our problem, we're going to cancel those units. So we cancel the kilometers, and then we have an answer in miles. And so when we do our math here, it's 48 divided by 1.609. That gives me 29.832 miles. And now we want to check that we have the correct amount of sig figs. 48.0 is 3.3 sig figs, so our final answer should have 3. So it's 29.8 miles is my final answer. And then reality check, does that sound right? Yeah, it's about 30 miles to get to Santa Monica from Pierce. If you were to drive when there's no traffic, it would probably take you about half an hour. If you're going 60 miles an hour, that makes about sense. So I would say yes, reality check, my number sounds good. Now we can also do conversions within the metric system. In this example, we want to know how many centigrams are in 3.52 grams. So we're going to follow the same process. We write down what we're given. So we are given 3.52 grams. We're trying to find centigrams. That's my unknown. And then I need a plan. How am I going to get there? What road am I going to take? Well, we learned earlier how many centigrams are in a gram. This is what we're going to use to create our conversion factor. So 1 gram contains 100 centigrams. That's why it's important to remember these prefixes. When I have the equality, I can set that up in a conversion factor. So I can go 1 gram divided by 100 centigrams, or 100 centigrams divided by a gram. Now I'm going to pick which conversion factor I want to use of these two that is going to cancel my units. So let's go ahead and solve the problem. We have 3.52 grams times, the one we want to cancel is 1 gram is equivalent to 100 centigrams. So my centigrams are at the top. I can cancel my gram units and get my answer. So then I just have 3.52 times 100 gives me 352 centigrams. And in this case, I have 3 sig figs, so I am done. How many milligrams are in 2.50 centigrams? So again, let's think about solving our problem. We are given 2.50 centigrams. We're trying to find milligrams. I didn't have you have to remember how many milligrams are in a centigrams. So this is actually going to be a two-step problem. We can go from centigrams to grams and then grams to milligrams. based on the information that I asked you to remember. So one thing is we can say 1 gram contains 100 centigrams, and 1 gram is equivalent to 1,000 milligrams. Now again, when we have equalities, we can use those to set up conversion factors. So we can take this as a two-step problem. So we start with 2.50 centigrams. We're going to be multiplying that by a conversion factor. So we can say, 1 gram divided by 100 centigrams, or 100 centigrams divided by a gram. We want to pick which one is going to cancel our units. So the one on the left has the centigrams, so we can set that up as 1 gram divided by 100 centigrams. Then you can see our centigram units cancel. We have 2.5 divided by 100 gives me 0.0250 grams. Now we are at this point right here. So now that we have our grams, we can go to milligrams. So let's write this down below, 0.0250 grams. Again, we want to set up a conversion factor so we can cancel units. And we have the option of a gram divided by 1,000 milligrams, or 1,000 milligrams divided by a gram, because they're equal. So again, we're going to pick the one that has the grams at the bottom, the conversion factor on the right. So we have 1 gram with 1,000 milligrams at the top. Now our gram units will cancel. So we have 0.0250 times 1,000 gives me 25.0 milligrams. So this is an example of a two-step problem where you have to think about, you have to make a plan. How am I going to go from one unit to the other if it's not a direct one-step process? So you may have multi-step processes coming up. My son drinks 2.5 quarts of milk a day. How many milliliters of milk is this? We want to always write down what we're given, which is 2.50 quarts. What we're trying to find is milliliters. Now, if we look on our table, we don't have a direct conversion from quarts to milliliters. We do have one where we can go from quarts to liters, and then we have to remember how to go from liters to milliliters. So looking at our table, we learned that 1 quart is equal to 0.946 liters. And then liters to milliliters, we know because we remember 1 liter contains 1,000 milliliters. Now we can go ahead and set up our problem so that we'll cancel units. So we start with 2.50 quarts. I'm going to create a conversion factor to cancel out my quarts. So 1 quart, write this up here, 1 quart is 0.946 liters, or I could say 0.946 liters over a quart. And I want to pick the one with the quart at the bottom so that my units will cancel. So I have 0.946 liters. Now the reason we're doing this, because any number divided by itself is always equal to 1. So 1 quart over a quart cancels, and that's 1. That's why we do all this setup like this. Now we could go ahead and solve for the answer here and get our liters and then convert to milliliters. I'm going to go ahead and set it up in one flow, let's say. So I'm at liters. I want to convert liters to milliliters. So same thing, I'm going to set up some conversion factors here. So a liter over 1,000 milliliters, or 1,000 milliliters over a liter. I want to pick the one that's going to cancel my units. So that's a liter at the bottom, 1,000 milliliters at the top. So now I set up my problem. It's a two-step problem, but I set it up all in one kind of flow here. And now I want to make sure all my units cancel. So I have a quart divided by a quart cancels out. A liter over a liter cancels out. And I end up with an answer that's going to be in some number in milliliters, which is what I'm looking for. So now I can just do the math. So I have 2.5 times 0.946 times 1,000, and the number I get is 2,365 milliliters. Now the last step whenever you're doing a calculation problem is checking your sig figs. The number we're given, 2.50, has 3 sig figs. So my final answer, since we're doing multiplication and division, has to have 3 sig figs as well. So I don't want to ever just drop that number. Sometimes people do this and they say their answer is 236. You can't do that because you're changing the value. 2,365 is not the same as 236. You could think about, let's say your friend owed you $2,000 and they only paid you $200. Totally changing the value of the money. That's not going to be acceptable. So never change the value. The only way we can make this have 3 sig figs is by putting our number into exponential notation. So let me just rewrite that again. Okay, so we have our imaginary decimal here, and I'm going to move that over 3 spots. So then I have 2.365 when I do that. I only want 3 sig figs. I'm also showing that I moved it over 3, so times 10 to the third. But what I need to do is I need to round my number. So instead of just dropping the 5, I am going to drop it, but I want to determine if I round the number, if I just drop it. Any number that's 5 or greater, I have to round the number next to it up 1. So this would be 2.37 times 10 to the third. Okay, so based on rounding rules, any number 5 or greater, the number next to it, you would round up 1. So if the number here was a 4, you would just drop that 4 and you'd have 2.36. So final answer is 2.37 times 10 to the third milliliters of milk. That's how much milk my son drinks in one day. Ampicillin is an antibiotic that's commonly used to treat ear infections in children. And whenever you're giving a child medication, it's always important to know how much they weigh so you give them the appropriate amount of medication. In this example, we're saying the daily dose of ampicillin for treating the ear infection is 115 milligrams of ampicillin per kilogram of body weight. What is the dosage in milligrams, that would be, of your ampicillin for a 34-pound child? So in this case, you're looking for, what you're trying to find is milligrams of ampicillin. And you're given the mass of the child in pounds. So we want the final answer to be in the metric system. So let's go ahead and convert the child's mass in pounds to the child's mass in kilograms, which is what the dosage is for. So we're going to take 34 pounds is what our child weighs, and we want to convert that to kilograms. And so we're going to go and need to look at a table to see how many pounds is equivalent to a kilogram. So looking at a table, we can say 1 kilogram is equal to 2.205 pounds. So we're going to create our conversion factor, a kilogram over 2.205 pounds, or 2.205 pounds over a kilogram. So let's set up this part of the problem. 34 pounds times, we want to cancel pounds, so let's put the one with the pounds at the bottom. 2.205 pounds is what 1 kilogram is equivalent to. So my pounds will cancel, and I'll get my answer in kilograms. So 34 divided by 2.205 is equal to 15.4195 kilograms. Okay, so that's the mass of our child. Now I do want to point out here we don't reduce this number to the correct amount of sig figs. Changing to the correct amount of sig figs is always done in the final step of your calculation. So at this point you want to leave all the digits on your calculator. Now in this problem we have the mass of the child and then we have the dosage. We're looking for the milligrams per kilogram of body weight. We're going to be using that. So that's a fraction. So anytime you're given two pieces of information and one of them is a fraction, in this case, the 150 milligrams per kilogram of body weight, that's going to be your conversion factor. And we're going to start with the mass of the child. So anytime you have a fraction given to you, realize that that is a conversion factor. You don't want to start with that. So we're going to write down 15.4195 kilograms. That's the body weight. Now we're going to times that by our fraction that's given to us. So that says 115 milligrams of ampicillin is the amount for every kilogram of body weight of our child. Okay, so the kilograms of the body weight cancel, and we'll end up with milligrams of ampicillin, the total amount that's given for the day. So then we just have to do our math. 15.4195 times 115, that gives me 1773.2 milligrams of ampicillin. And now we want to check our sig figs. So the numbers given in the problem, they both have 4 sig figs. 34.00 and 115.0 are both 4 sig figs. My final answer should have 4. So it's 173. We drop the 2 milligrams of ampicillin.